Find the image height, image distance, and magnification of the image created by this two-lens combination. It's a two-lens combination, so light beams from the object on the left are going to travel to the lens. They'll be refracted in most cases by the first lens. Then that lens is going to form an image called I1 here. As you can see, I1 is an inverted image. It just obeys the same principles that the previous examples did. But then what's going to happen is that image I1 will be used as the object for lens 2. So there's two parts to solving this. We want to start with lens 1. Alright, so one of the formulas we had used in the past was the thin lens formula. And we just want to apply it to lens 1. In order to apply it to lens 1, I'm going to just write it in a little bit different way. I'll write 1 over dO1 plus 1 over di1 equals 1 over f1. See, I want a subscript of 1 on all these terms because we're going to have another formula for lens 2. Alright, they're saying that the focal length of lens 1 is 10 centimeters. They also show that the object is 30 centimeters in front of it. So we want to do 1 over 30 plus 1 over di1 equals 1 over 10. Alright, let's solve that. And I get that the distance of image 1 is 15 centimeters, and that agrees with what we see in the diagram here. Alright, so we're also going to want to find the magnification of lens 1. So let's do negative di1 over dO1. It's negative 15 over 30, which is negative 1/2. Alright, we'd also like to know the height of image 1. The height of image 1 will be the magnification times the height of object 1. Now, they didn't give a height. Alright, so it's going to be negative 1/2 times the height of object 1, whatever that may be. That's everything that we need to know for lens 1. Now we want to do another calculation. Thin lens formula for lens 2. Alright, so it's going to be 1 over dO2 plus 1 over di2 equals 1 over f2. Alright, they say that lens 2 has a focal length of 20 centimeters. But we technically don't know the distance of object 2 just yet. We have to find it. We do know that this distance here from lens 1 to image 1 is 15. But how far away is that image from lens 2? Because that's what we need to find in order to know what the distance of object 2 is. So, in order to find it, we have to know how far apart the lenses are from each other. They say in the picture that they are 20 centimeters apart. And we know that the distance from lens 1 to the image is 15 centimeters. So that will lead us to a calculation here that the distance of image 1 plus the distance of object 2 has to equal the lens separation of 20 centimeters. Okay, remember this here is DI1. Alright, so we would plug in the image distance that we had found, and we could solve for the distance of object 2 now. It looks like it's going to be 5 centimeters. Alright, so that's a critical extra step that we didn't have to do in the previous problems. Now let's plug in. We'll have 1 over 5 plus 1 over DI2 equals 1 over 20. 20 is the focal length of lens 2. Alright, solve that for DI2. And we get negative 6.67 centimeters. The negative indicates that the image for lens 2, it'll be on the same side as the object for lens 2. I1 is the image of lens 1. Okay, but it is also the object of lens 2, so it serves two roles there. It's both. Alright, when they talk about negative 6.67 though, we are talking about the distance from lens 2 to image 2, which happens to be in front of lens 2. Alright, so that is that. We know the final image distance, but we also want to find the magnification of lens 2. So now I have to be more specific. Over here I said m was negative 1/2, but which m is it? It's the m of lens 1. And now we have to find what's called m2, the magnification of lens 2. So we'll do this. Apply the magnification formula to lens 2. Okay, so that gives us 1.33, or in other words, 4/3. Okay. One of the other things we're interested in with this is finding the total magnification and the total final height of image 2. I'm going to go on to find what is called M total. This is the total magnification of the whole system, and you find it by multiplying M1 times M2. Alright, so let's plug in. M1 was negative 1/2. It cuts our object's size down by 50% and it inverts it. Then we have a second lens which will actually increase the size of the image, but it will not invert it this time. Alright, so if we just multiply here, looks like we'll get negative 2/3 as our final magnification. This means that image 2 will be 2/3 as large as object 1. So if object 1 has a certain height, call it HO1, then our image 2 will have, a height of HI2. And now we just want to relate those two things. So we'll do that down here. And we'll say HI2 will equal the total magnification times HO1. Alright, so we don't have a height for our object, so we can't plug that in, but we can just plug in the negative 2/3 here. And that tells the relationship between the image height and object height.